Okay, I have a couple more examples to finish section 5.1. Example 7 says find an equation of a parabola that passes through three given points. We know the equation of a parabola is y equals ax squared plus bx plus c. And so we just need to find the a and the b and the c. And so that might be a nice thing to start with. Find a, b, and c. And so we're given x and y that we can plug into this equation, and so let's do that. So the equation says ax squared plus bx plus c equals y. I've switched the y over to the right side, and so now I want to take x equals -2 and y equals 4, and I want to plug in. And so what do I get? The -2 goes in for x and gets squared, and so -2 squared is 4, and so I have 4a plus bx. Now x is -2, so that would be plus -2b, or just -2b, plus c is equal to the y value, which is 4. And so here's an equation in three unknowns, a, b, and c. And can you see that we'll get two more equations like that, and then we'll have a 3x3 system that we can solve. If we have x equals 2 and y equals 2, then 2 squared makes 4 times a, plus b times 2, or plus 2b, plus c is equal to 2. And then in the last equation we have x equals 4 and y equals 9. And so we have x is 4 squared times a, so 16a, plus bx, x is 4, plus b times 4, plus 4b, plus c is equal to the y value 9. So here is the system of equations, and it would be good to go ahead and number those equations. And then, we talked in the last video about how to solve a system like this, so you might want to pause the video and try to solve this system for yourself. Okay, so what we need to do to solve the system is we need to pick a pair of equations and eliminate one of the variables. Maybe the easiest way would be to choose equation 1 and 2 and eliminate b. So let's try that. So 1 and 2, and eliminate b. And so all I have to do is just add the two equations together, and you can see that the coefficients on b are opposites, so they'll cancel out right away. What are we left with? We're going to be left with 8a plus 2c is equal to 6. And so that's a good start. And so then we just need to pick a different pair of equations and eliminate the same variable. So this time let's choose 1 and 3. And eliminate b again. And to eliminate b, I'll have to multiply the first equation by 2. Multiply equation 1 by 2. And so then I'll get 8a minus 4b plus 2c equals 8. And the third equation, I can just copy it down. 16a plus 4b plus c equals 9. And when I add these together, I get 24a, b's cancel, plus 3c equals 17. Okay, so let's go back and call this equation number 4 with just a and c, and now this is equation 5, also just with a and c. And so then we're just going to solve the 2x2 system now with equations 4 and 5. So we're going to solve 8a plus 2c equals 6, and 24a plus 3c is equal to 17. It's easy to make a careless mistake. I'm checking my work and trying to make sure I haven't got anything wrong yet. Okay, if we want to solve this system, there are a couple ways to do it. Maybe the easiest way is just to multiply the first equation by -3, and that'll get us negative 24a minus 6c equals -18. And then when I add the equations together, the a's cancel and I'm left with negative 3c equals -1, or c is equal to positive 1/3. So that's a good start. Here, let's just put a star next to that. I guess I won't put a box around it. It's not really the answer, but it's one piece of it. So I could go ahead and solve for a now. I can go back to one of the equations I started with. I could go back to 8a plus 2c equals 6, and I can put in 1/3 for c. And you might be saying that the problem would be easier if we would have canceled the common factor right up here. There's a common factor of 2 in the equation to begin with. You're right. If I would have cleared that 2 out, I would save myself a little bit of work. But I'll push on through with what I've got. It'll be okay. So let's just go ahead and solve for a. And I guess the way we learn to handle this is to multiply by the least common denominator, which is just 3. And so then we'll get 24a plus 2 equals 18. We can subtract 2 on both sides and get 16. And then when we divide 16 by 24, that simplifies to 2/3. So there's our value for a, and we still need to get the value for b. So let's go back and get one of those original equations, maybe the very first one. 4a minus 2b plus c equals 4. 4a minus 2b plus c equals 4. Let's make sure I wrote that down right. 4a minus 2b plus c equals 4. Looks good. Okay, and then I can go ahead and plug in the values for a and c that we already have. So that's 4 times 2/3 minus 2 times b plus 1/3 is equal to 4. And let's see here. 4 times 2/3 is 8/3, right? Multiply numerator times numerator. That's 8/3 there. Plus 1/3 makes 9/3. 9/3 is just 3. So 4 times 2/3 plus 1/3 just makes 3. So 3 minus 2b equals 4. And we can subtract 3 from both sides and get 1. And so b is negative 1/2. Great. And then there's just one more step, and that's to go ahead and write the final answer. So if you recall, when we're writing the formula for a parabola, we want y equals ax squared plus bx plus c. So this particular parabola has a coefficient a equal to 2/3. b is negative 1/2. So we'll write minus 1/2 times x plus c is plus 1/3. And there's our answer. It might be fun for you to go on the computer and find a website where you can graph this function and see that it actually passes through the points. Or another way to verify that that this function passes through the 3 given points is just to check, is just to plug in the x and y combinations and into this answer and see that they make true statements. Okay, one more problem. Example number 8. Solve the system in terms of the arbitrary variable x. So again, we have 3 variables in each equation, but this time we only have 2 equations. And so we would expect to have an infinite number of solutions, or possibly to have no solution, although I can tell you that's not the case. We'll have an infinite number of solutions. We don't have enough equations to just get one solution. We would need a third equation in order to get one solution, the way we did in the previous example. Okay, so the trick here is to solve in terms of the arbitrary variable that we want to be x. And so what that means is that we need to keep x around. We need to eliminate one of the other variables, and it doesn't matter which one. So we want to eliminate y or z. So let's just go ahead and, well, let's eliminate z. So we'll multiply the second equation by 2. And that'll get us 10x plus 4y plus 2z is equal to negative 12. And the first equation, we'll leave it alone. 3x plus y minus 2z is equal to negative 7. And so when we add those together, we have 13x plus 5y equals negative 19. So if we want the arbitrary variable to be x, then we want to solve for the other variable in terms of x. So we're going to solve for y. So we're going to solve for y. And so if we subtract 13x from both sides, we get 5y is equal to negative 13x minus 19. And then if we divide by 5 on both sides, then we have the denominator 5. Okay, so that's half of the answer right there. So remember, our answer is going to be an ordered triple x, y, z. There are an infinite number of answers. There are an infinite number of ordered triples. And so to describe them, we're going to leave x free to be any real number. And then we want to write y in terms of x, which we just did. And then we want to write z in terms of x, which is what we're going to do right now. There are two ways to do this. We could come back and eliminate y from the two equations, from the two original equations, or what I would prefer to do is just to use substitution to solve for z. So what I'm going to do now is I'm going to take the result that we just got, and I'm going to plug it into the first equation. So 3x plus y, and now y is negative 13x minus 19 over 5 minus 2z equals negative 7. And so then you see I have an equation with just the two variables x and z. I can solve for z. And then I can write my final answer. So solve for z. And I'd like to start just by clearing out the fraction 5. So I'm going to multiply both sides of the equation by 5. And that will get me 15x minus 13x minus 19 minus 10z is equal to negative 35. Remember solving for z. So let's have the 19 go to the other side. And let's put the x's together. 15x minus 13x is 2x minus 10z is equal to negative 16. And we just have a couple more steps here. So actually you see a common factor of 2 in all of the terms, and so it would be good to just divide that off. We don't have to, we could deal with it later, but we can do it right now. Okay, so let's keep going. Let's solve for z. Let's subtract the x to the other side. Or even better than that, with all these negative signs here, you know what would be nice is if we added 8 over to the left side, and we added 5z over to the right side. That would make all the coefficients positive, and then z is equal to x plus 8 over 5. And so that's the other part of our answer. Remember, we said the answer is an ordered triple x, y, z, where x is arbitrary. So we're going to write x. And then y is negative 13x minus 19 over 5. And then z is x plus 8 over 5. And that's it. We could put the braces around it. We could come back and get a particular solution if we wanted to, if we just substitute any value of x into these other two expressions. So for example, If x is 0, then y is negative 19 over 5, and z is 8 over 5. So that would be one particular solution. Here's our answer, and we're all set. We finished section 5.1.